Today's lesson is on rational expressions. A rational expression is a fraction whose numerator and denominator are polynomials. So it's basically just a fraction, and you're going to have something with x on the top of the fraction and something with x on the bottom of the fraction. Recall from our work with fractions that the denominator cannot be equal to 0. The value of x that makes the denominator 0 is called the excluded value. The excluded value. This is what x cannot be. It is the value of x that makes the denominator 0. The value of x that makes the denominator equal to 0. One of the things we're going to need to do is find the excluded value for our rational expressions. To find this, there's a couple steps. Set the denominator equal to 0. And then solve for x. Let's take a look at a couple examples. So the problem will say find the excluded value or values. The first one is 3x minus 2 divided by x plus 7. So what we're looking for is what number do I plug in for x that will make the denominator of this fraction 0. So all I do is I take the denominator, x plus 7, set it equal to 0, and then solve that. So x is equal to negative 7. What this really means is that x cannot be a negative 7, because when x is a negative 7, the denominator of my fraction is 0, so my excluded value is negative 7. Let's look at another example. 6x plus 3 divided by 4x. Again, what value of x makes the denominator of this fraction equal to 0? So let's take 4x, make it equal 0, and by dividing both sides by 4, x equals 0. So 0 is my excluded value, because x cannot equal 0. Sometimes you need to factor the denominator, as in this example. 5x squared minus 2 divided by x squared minus x minus 12. Okay. So what I need to do is, again, set my denominator equal to 0. And to figure out what this is I need to factor the trinomial. So if you recall, I'm looking for two numbers that multiply to negative 12, and the same two numbers add up to a negative 1. So that's going to be x minus negative 4 times x minus 4 times x plus 3. So each of those equals 0. So x equals 4. And x equals negative 3. In this case, I have two excluded values. If x is 4, my denominator is 0. If x is negative 3, my denominator is 0. And let's take a look at one more example of this. 3 divided by 2x squared minus 4x. Take your denominator, set it equal to 0. In order to solve this, I need to factor out a greatest common factor of 2x, and that will leave me with x minus 2. So that means 2x equals 0, or x minus 2 equals 0. So one of my excluded values is 0, and the other excluded value is 2. If x is 0, my whole denominator is 0. If x is 2, my denominator is equal to 0. Next thing we're going to do is simplify some rational expressions. Here are the steps you need to follow to do that. First thing you want to do is factor the numerator and the denominator. Factor the numerator and the denominator. Second thing you want to do is see if there's anything you can cancel. Do you have any similar factors on the top and on the bottom? That should simplify the rational expression, but then you also have to find any excluded values. Okay, let's take a look at several examples. Simplify each rational expression and then state the excluded values. So 32x to the 5th y squared over 4x y to the 7th. Okay, we're going to simplify this like we did back in, I think it was the beginning of chapter 8. I'm going to look at the numbers first. 32 on the top and a 4 on the bottom. Leaves me with an 8 on the top. 5x's on the top, 1x on the bottom. Leaves me with an x to the 4th on the top. And 2y's on the top, 7y's on the bottom. Leaves me with 5y's on the bottom. So my final answer is 8x squared divided by y to the 5th. Now to find our excluded values, I will take my original denominator, not my simplified denominator, and set it equal to 0. I can divide both sides by 4. So xy to the 7th equals 0. My two excluded values are going to be 0. So x cannot be 0, and y cannot be 0. Because if x is 0, my whole denominator is 0. If y is 0, my whole denominator is 0. Here's another example. 12x plus 36 divided by x squared minus x minus 12. First step is I need to factor both the numerator and the denominator. On the top, I can take out a greatest common factor of 12, and that leaves me with x plus 3. And on the bottom, I have a trinomial, so I'm looking for two numbers that multiply to negative 12 and add to a negative 1. So that's x minus 4 and x minus 3. I'm sorry, x plus 3. Now I can cancel. My x plus 3's will cancel, and I am left with 12 over x minus 4. The 12 on top and the 4 on the bottom cannot be canceled. You can only cancel stuff that's being multiplied. Okay, in this case, in the previous step, we had 12 times an x plus 3 in parentheses, and then on the bottom an x minus 4 in parentheses and an x plus 3 in parentheses. Because everything was multiplied, we could cancel the x plus 3's. Now, to find my excluded values, I'm going to take my original denominator, but actually I'm going to use it in factored form. X minus 4, x plus 3. Set it equal to 0. So my two excluded values are x is 4 and negative 3. So x cannot be equal to 4, x cannot be equal to negative 3, because both of those values will make your denominator 0. Let's take a look at another example. X squared minus 2x minus 35 divided by x squared minus 9x plus 14. Now the temptation here is to cancel the x squareds, because you have an x squared on the top and an x squared on the bottom. But the x squareds are being added and subtracted with other stuff. Simple rule to remember is that you can only cancel stuff that's being multiplied. You can only cancel stuff, factors, that are being multiplied. Those x squareds are not being multiplied by anything. On the top it's having 2x subtracted from it and a 35 subtracted from it, so you cannot cancel anything yet. Next thing we need to do is we have to factor each of those. So two numbers that multiply to negative 35 and add to a negative 2 are negative 7 and positive 5. And on the bottom, two numbers that multiply to a positive 14 and add to a negative 9. That would be an x minus 2 and an x minus 7. Now that my rational expression is factored, now I can cancel. Factor first, then cancel. And I can cancel the x minus 7s. So my final answer is x plus 5 over x minus 2. And I cannot cancel those x's because the top one is having 5 added to it and the bottom one is having a 2 subtracted from it. That's not multiplication. You can't cancel. So to find my excluded values, I'll take my factored denominator, original factored denominator, set it equal to 0, and solve each one of those. So my two excluded values are 2 and 7. So when x is 2, my original denominator is 0. When x is 7, my original denominator is 0. I'd like you to try the following problems in your composition notebook. On page 586, I want you to do numbers 1, 5, and 7, and I will check those in class on Monday.